Okay, let's take a look at another stoichiometry reaction in solution here. This one's going to be a little bit different from the last one because now I'm asked to find the limiting and excess reactants. So now we're getting into a little bit more here, but that's okay. We'll walk through it. First thing I'm going to do is double check to make sure I have a balanced chemical equation. In this case, it has already been balanced for me. And then what I like to do is just kind of read through the problem and almost box in the information that's given to me. And then I like to pull that information and put it down right underneath the chemical equation. So I'm given just a small amount of information about zinc and then a couple of things about this HCl here. So let me clear all that off. First thing I need to do if I'm trying to identify limiting and excess reactants is I gotta find moles. I need to know moles of both of my reactants before I can answer that question. So that's exactly what I'm going to do. To find moles of zinc, that's a pretty simple flip. We've been doing that forever. All I'm going to do is take the 79.1 grams of zinc and just quickly convert to moles. So I need the molar mass of zinc off the periodic table. You should see it 65. And then 1 mole goes up top. So once you divide by 65, you should end up with about 1.22 moles of zinc. Perfect. Now I have moles of this reactant. I'm going to have to find moles of my second reactant so I can compare values and do a couple more calculations. So let me quickly get moles of HCl. When I look at the information that's given here for HCl, I can't go from grams to moles because obviously I don't have grams, but I can plug that stuff into my molarity equation and then solve for moles. So again, my molarity equation equals moles per liter. In this case, once I plug in all that information, I would plug in 2.5 molar for my molarity. Again, moles is unknown. And then 0.9 liters for my volume. Wonderful. How do you solve for moles? You will have to multiply your molarity times your liters. Again, if you've never seen this triangle, I'll show it to you one more time. This is a relatively handy little triangle here. If you write the molarity equation in a triangle and then cover over your unknown variable, in this case moles is unknown, it will tell you how to solve for that unknown. So in this case we multiply by molarity and liters, multiply those two. So once you multiply that out, you should get a mole value of 2.25 moles, and that's of HCl. Perfect. Now I've got some useful information here. I have both of my reactants in moles. And you can't just grab and say, oh, well, I have more HCl, that means that's going to be in excess, and just be done from there. No, you cannot do that because you have to take into account these ratios. So we have ratios kind of built into this equation here. And in this case, it's a 1:2 ratio. 1 mole of zinc will react with 2 moles of HCl. So I'm going to just pick one. It doesn't matter which one I pick. You can do either one. For me, I'm just going to grab HCl, just because kids always think that's the one in excess, because there's more moles. So I'm going to take my moles of HCl, which is 2.25 moles HCl, and I'm going to do a little mole-to-mole conversion here. If I have moles of HCl in my numerator, that means I have to have moles of HCl in my denominator to come cancel. And then I'm going to actually look for moles of my other reactant. In this case, my other reactant is zinc, so I'm going to put moles of zinc up top. And now the fun begins. Now I got to look at my mole ratios. What is the mole ratio here of zinc to hydrochloric acid? Well, it looks like it's going to be a 2:1. I'm going to pop that 2 down below, the 1 up top. And now I'm going to go ahead and solve this equation. Punch in your calculator 2.25 times 1 divided by 2. You should end up with 1.125 moles of zinc. Awesome. So what the heck is this telling me? Why did I just do this extra little mole-to-mole conversion? What's the point of this? This is actually telling me if I use all 2.25 moles of my hydrochloric acid, I will need 1.125 moles of zinc. That's how much I would need to hypothetically use all of my HCl. So the question is, do I have that much? Do I have more than 1.125 moles of zinc? And when I compare it to how much I'm starting with 1.22, the answer to that question is yes, I do have that much. Actually, I have a little bit over. Not much, but there is more left over. So yes, I have enough. That means I'm going to have plenty of leftover zinc. Zinc is going to be in excess, and I am running out of HCl. So that's the whole reason why I did this calculation down here below in green, is to tell me which one's going to run out first. So let me just clear this all away and put my final answer up here. Limiting, again, is going to be HCl because I'm running out of it. And then excess is going to end up being my zinc. And I was able to see that by comparing how much I would have to use if I used up all of my HCl, and then just comparing it to what I have in the beginning. This has been a Rodriguez original production. I hope you enjoyed. Go back, study your notes, do more example problems. Good luck.